Have you ever stopped to wonder what an AI really remembers from all the data it's trained on? Well, it turns out sometimes it remembers way too much. We're going to break down this kind of hidden vulnerability that can actually expose super sensitive information and, more importantly, how you can stop it. So let's just dive right in.
Okay, just picture this for a second. This isn't some sci-fi movie plot. This is a very real threat. Your company's powerful AI, this tool you've come to trust, could be hanging on to secrets it was never ever supposed to keep. And a clever attacker? They might be the only one who knows the right question to ask to unlock them. This is the absolute core of what we're talking about today.
So there's actually an official name for this: training data extraction. You can think of it like a digital heist. But instead of cracking a bank vault, the target is the AI's memory. And the prize? It's those specific word-for-word pieces of information that the AI accidentally memorized while it was learning.
So how does a heist like this actually work? You might be surprised. It's a pretty straightforward process that really exploits the way these models are built from the ground up. Let's walk through exactly how they pull it off.
It all kicks off with the training data. First, the model is just fed these enormous piles of information, and somewhere buried in there are people's real secrets. Then, something interesting happens. Instead of just learning the general ideas, the AI latches onto one very specific piece of data, say a credit card number, and just stores it, word for word. Now, fast forward a few months, an attacker shows up. They don't have to hack anything, they just have to ask the right question. A really strategic query like, my credit card number begins with 4111, and then, boom, the AI, trying to be helpful, just serves up the rest of the secret, completing the number it memorized all that time ago.
So, if you boil it all down, you get this really simple but pretty dangerous pathway. You've got sensitive info from the training data that gets baked directly into the model's core programming, what we call its weights. And from there, it just sits and waits for the right question to pull it right back out into the open.
And that brings us to a really fundamental point about how these systems even work. See, this whole vulnerability exists because of a sort of glitch in our understanding of what the AI is actually doing. It really all comes down to the difference between memorizing something and truly learning it.
So yeah, why would it even happen? I mean, we think of AI as this brilliant mind, right? Something that's capable of generalization and abstract thought. So why would it fall back on something as simple and frankly as dangerous as just rote memorization?
While the core problem is a flawed assumption we all make. We think the AI is learning abstract concepts, but what it's really doing is acting like a super powerful compression machine. And you know what? Sometimes the most efficient way to compress a rare piece of data is to just store the whole thing.
And this right here really illustrates the difference perfectly. On one hand, you have the goal, right? What we want is learning, generalizing patterns, creating these abstract ideas, building knowledge that it can apply to totally new situations. But on the other hand, you have the glitch, memorizing, just storing text verbatim, spitting back raw facts, and having this really fragile recall that only gets triggered by very specific prompts.
And here's the real kicker. Once that secret is baked into the model's weights, getting it out is, well, it's almost impossible. You can't just tell the AI to forget it. This makes preventing the problem in the first place, not reacting to it later, the only real strategy you've got.
Okay, so we get the problem. It's pretty scary stuff. But the good news is there are very concrete things you can do to defend against these extraction attacks. It's all about building a kind of fortress around your AI's memory.
The question then is, what does that fortress actually look like? How do you proactively stop your AI from turning into a huge liability? Let's get into the 4 key defense strategies and see how this all comes together.
All right, there are basically 4 main layers of defense here. First, and honestly, this is the most important one, is PII scrubbing. That just means cleaning your data before you train, getting rid of names, addresses, credit card numbers, all that stuff. Second, you've got differential privacy. This is a pretty clever trick where you add just a little bit of mathematical noise to the data. It's enough to protect privacy without really hurting the model's performance. Third is output sanitization. Think of this like a bouncer for your AI. It checks the answers for secrets before they can get out the door. And finally, canary tokens. These are fake secrets you plant in the data that act like little silent alarms if an attacker ever manages to extract one.
But of all those strategies we just talked about, this is the one you really need to remember. The number one rule, the most effective defense, is the one that happens first. Proactively finding and removing all that sensitive information from your training set is the absolute best way to guarantee it never gets memorized. Everything else is just a backup plan.
And that really leaves us with this final thought, which is the ultimate takeaway. It's a simple but incredibly powerful rule. The data you feed your model, that becomes its world, its memory, its entire reality. So if there's anything at all you wouldn't want revealed to the world, you have to make sure it never, ever becomes part of that AI's world in the first place. Period. It's really that simple.